Hello, welcome to Maths with EJD. In this video, I'll be starting a series of teachings on trigonometry, which I know is something very well known, probably in mathematics, but then I know a lot of people have issues dealing with uh cases relating to trigonometry. So this set of videos will be so helpful to you if you find trigonometry really difficult, because I'm going to take it from the very scratch till we get to the very advanced sides. Okay, so let's go on in this whole thing. Now, I like to always start teaching trigonometry by breaking down the actual word. What is trigonometry? What does that mean? Now, if you look at the word, right, you can break it down into three syllables, like, or is it three syllables, or I just break it down into three components, maybe not necessarily syllables. So you have trigono and metry, trigono and metry. And what does that mean? From the word tree, you know, uh tree simply means three, as you can imagine. Gono talks about angles, right? Gono talks about angles, and metry talks about measurement. Metry talks about measurement, basically. So it simply means that trigonometry is three angles measurement. And now that takes us to the idea, that brings us to the idea of three angles. Like, what shape is there that has three angles? Basically, that will be triangles, right? Triangles. Because a triangle, a triangle has, okay, maybe to be a bit more formal, right? A triangle is a plane shape, is a plane shape, is a plane shape with three sides, and three angles. And trigonometry is three angles measurement. So a triangle is a plane shape with three sides and three angles. Okay, three sides and three angles. So you see three angles coming up here again. So basically, it means that trigonometry is about triangles. Okay, and that takes us to the idea of triangles, right? So since we've established that trigonometry is three angle measurement, and the shape that has three angles is actually called triangle. Now, so one particular kind of triangle actually stands out when we talk about trigonometry, and that is the idea of right angle triangle. So trigonometry is basically about triangles, most especially right angle triangles. But before we go into all that, right, can we talk about triangles, on its own? Let's talk about triangles. Triangles. So basically, triangles can be classified based on the type of sides they have, based on sides, and they can also be classified based on the angles they contain, right? So these are like some possible classification of triangles. So you can classify based on sides and based on angles. So talking about classification based on sides, right? Uh classification, classification of triangles based on based on sides. You know, we have the first thing we like to talk about here would be will be equilateral triangles. Equilateral triangles. Now the word equi means equal, as you can already imagine, and lateral is side, so that's equal sides. So equilateral triangles have equal sides. So it's a triangle like this, where you have, all the sides are equal, and we denote that by the number of strokes we have on each side. So all the sides are equal. And one thing we need to know about triangles is that the angles facing a side is proportional to it. So that means that, if you have, okay, I'll talk about other types of triangle, right? Since all the sides are equal in equilateral triangle, it means that all the angles are also equal, because the angle facing a triangle, facing the side of a triangle, is proportionate to that angle. So the longest angle the biggest angle faces the longest side, and the smallest angle faces the shortest side, basically. But in the case of equilateral triangle, where all the sides are equal, all the angles are also equal. And since you know that sum of angles in a triangle, sum of angles in a triangle, sum of angles in a triangle is 180 degrees. So if you add up all the angles in a triangle, it's 180 degrees. So for the sake of for the case of equilateral triangle, since all the sides are equal and all the angles are equal, then it means that each angle of an equilateral triangle is 60 degrees each, basically. Since even if you don't know what the length of the side, as far as all the sides are equal, then automatically all the angles are equal. And since we know that the sum of angles in a triangle is 180 degrees, then each angle of an equilateral triangle is uh is 60 degrees. Okay, so let's talk about the second type based on that's classification based on sides now. So let's talk about isosceles triangle. Isosceles triangle. Now, in the case of isosceles triangle, right, you have two sides equal, like this side and this side is equal, but then the third side is different. So you have two equal sides, and then you have the third side different. So, and facing this side is an angle that is proportionate to it. And since this side is equal to this side, the angle facing this side also, which is this, is also the same as this. So these two angles are actually the same. For perspective, let me draw just one stroke for each. Okay. So since this side is equal to this side, so it means that the angle facing this one is this, and the angle facing this one is this way, you know. So it means this angle and this angle are the same. Automatically, the third angle, which is facing the other side, is will have this double stroke. So it means that, and that is why we say that the base angles of an isosceles triangle are the same. So if this is A, this is also A. And then this can now be, since the sum of everything is 180 degrees, so this can now be 180 degrees minus 2A, something like that. So that is an isosceles triangle. So all two sides are equal and the third side is not. So here, what do we have? In equilateral, we say all three sides equal. All three sides equal. That's the case of an isosceles of an equilateral triangle. But for an isosceles triangle, only two sides, only okay, or let me put it this way. Let me just say two equal sides. Two equal sides. So the third side is just different from those two. So two equal sides. Okay. So let's go to the third one, which is what you can call scaling triangle. Triangle. Scaling triangle. Now, for a scaling triangle, right? All the sides are different. All the sides are like, um, I hope I get this right. Okay, well, I mean, however I draw it, right? Just know that all the sides are not the same. So you have this side, and you have this side, and you have this side. So they are all totally different. So let's assume this is the shortest side. So the shortest side, like I said, is going to be facing the smallest angle. And let's say this is the second side to that. So the second side will be faced by the second angle, the medium angle, right? And if this is the longest side, then automatically, this angle will be proportional to that. So the biggest angle faces the longest side. That is the idea of a scaling triangle. So uh no side, okay, or let me say put it this way, all sides are different. All sides are different for a scaling triangle. All sides are different. Now, one thing that is remarkable is that when you go back to equilateral triangle, right? I told you that since trigonometry is triangle measurement, right? And the most important triangle, talking about triangles, is actually right angle triangle. You discover that for an equilateral triangle, you can easily draw what you call an altitude. An altitude is simply a height. So if you draw the altitude, it will make 90 degrees in the case of equilateral triangle. So if you come to scaling triangle, you can actually draw the same. So since both equilateral and isosceles triangles are they are what you call they are symmetric, So this is symmetric, meaning that you can divide them into two equal parts. So equilateral triangles are symmetric. Isosceles triangles are also symmetric. You can divide them into two equal sides. Now, for the case of scaling triangle, right, you can actually drop an altitude, right? You can drop an altitude, which will make 90 degrees. But you can see that it is asymmetric, meaning that you cannot divide it into two equal parts. So that is the idea of a scaling triangle. All right. So the next thing I like, so now we have talked about the classification of triangles based on sides, like their equilateral triangles, isosceles triangles, and of course, equilateral triangles, isosceles triangles, and of course, scaling triangles. Now, can we talk about classification of triangles based on angles? Classification, classification, classification of triangles, classifications of triangles based on angles. Now, we've talked about based on sides, and a triangle has three sides and three angles. So classification of triangles based on angles now. So first here, we talk about what we know as acute angled triangle. Acute, or in this case now, maybe the first thing we should even talk about is, let's talk about the spectrum of angles we have, right? So talking about the different angles we have 0 degrees, like some kind of angles we need to be referring to. 0 degrees, you have so you have 0 degrees, right? You have 90 degrees. You have, or let me extend, allow for some space. You have 0 degrees, you have 90 degrees, you have 180 degrees, and you have 360 degrees. These are very important, right? Or better still, I can do it into the four quadrants, and this is what the four quadrants look like. So here you have 0 degrees. So from 0 degrees, you have 90 degrees. After that, you have 180 degrees. After that, you have 270 degrees. And lastly, you have 360 degrees. Okay, maybe this quadrant thing is not the best to use. Yeah, because from 180 to 360 degrees, it's like we can put it all together. Or okay, well, I guess I can still use this, right? So here now, um, any angle between zero, any angle between 0 and 90 degrees, you can call it acute angle. Acute angle. Any angle between 0 and 90 is acute. Then any angle between 90 and 180 degrees is called obtuse. It's called obtuse. Then any angle between 180 and 360 degrees is called reflex. It's called reflex. So as such, we can have okay, of course, we have zero angle, right? We have zero. Okay, well, that is why I think I prefer not to use these four quadrants. The four quadrants is going to be useful in another situation. It's going to be useful in another situation. So let's leave this out and just write out the angles the way they are so we can follow through. So you have, first of all, 0 degrees, you have 90 degrees, you have 180 degrees, and you have 360 degrees. So I need to understand that any angle between 0 and 90 degrees is said to be acute. Said to be acute. In this case, you have 0 degrees is less than or equal to theta, is less than, oh, not less than or equal to, between, right? So you have 0 degrees less than theta. Theta is the angle less than 90 degrees. And that is what you see to be acute angle. And then you have 90 degrees itself now is said to be right angle. 90 degrees is said to be right angle. So in this case, theta is just exactly 90 degrees. And then from that now, you have between 90 degrees and 180 degrees, you have what you call obtuse angle. Obtuse angle. Acute angle here. So you have obtuse angle. Okay. So for obtuse angle, you have 90 degrees is less than theta is less than 180 degrees. That means that the angle, an obtuse angle lies between 90 degrees and 180 degrees. And then you have 180 degrees itself. That is what you can call a straight angle because it's a straight angle because it is the sum of angles on a straight line. Straight angle, straight angle. That is where theta is 180 degrees. So remember, if you have a straight line and you have different angles meeting, so if you add all these angles together, they all add up to 180 degrees. That is why we call that a straight angle. And of course, we move on and we have between 180 degrees and 360 degrees. Between 180 and 360 degrees, we have what you call reflex angle, reflex angle. So in the case of reflex angle, it means you have 180 degrees less than theta, less than 360 degrees. So in this case now, we move down to 360 degrees, right? For 360 degrees, we say that it is actually a revolution, or sum of angles at a point. So that's a revolution where theta is 360 degrees. Now, based on this angle, we can actually have triangles too, right? We can have triangles. So first of all, we have acute angled triangles. Acute angled acute angled triangles. So that is a triangle that contains an angle less than 90 degrees. So let's assume you have the straight line and then you have you have this theta, which is less than 90 degrees, something like this. So as far as there's this angle here, so you can say this is an acute angled triangle. So here you have an angle that is less than 90 degrees. Okay. So the next thing is you also have the next angle after acute angle is right angle. Interestingly, we also have what you can call the right angle triangle, right angled triangles or a right angle triangle. So here it means in this case now you have a triangle that contains an angle of 90 degrees, that contains a right angle. So let's say this is 90 degrees. So, and these are very important kinds of triangles as you are going to see along the line as we go on in trigonometry. And then after this now, we have what you can call the obtuse angled triangle. Obtuse angled triangle. Since you already know, obtuse angle lies between 180 and 360 degrees. So obtuse angled triangle. Obtuse angled triangle. So for an obtuse angled triangle, you have, say that you have this, and then you have something more than 90 degrees, but less than, okay, uh, yeah, this is obtuse angle, right? Is between 90 and 180, yes. So this is obtuse angled triangle, right? So this is an obtuse angle. So that's an obtuse angled triangle. So because you have here 90 degrees is less than theta is less than 180 degrees. So there's an angle, this theta now is between 90 and 180 degrees. And here theta is just 90 degrees because it is a right angled triangle. Here you have theta, you have 0 degrees less than theta less than 90 degrees, right? Like that. So theta between 0 and 90 degrees, right? That's acute angle triangle. Right angle triangle, theta is 90. Obtuse angle triangle, theta is between 90 degrees and 180 degrees. And then beyond this, right? You don't have, there's nothing like, you don't, if you, there's nothing like straight angle triangle because that's 180 degrees. So that's just a straight line. And there's nothing like reflex angle triangle because a reflex angle triangle is already is back to. So if you think about the idea of a reflex angle triangle, right? So you have this straight line and then you have the whole angle to be more than 180 degrees. So there's nothing like this because at the end of the day, once this side is reflex, the other side is automatically acute. So it's as good as talking about another acute angled triangle. So I'll stop in this video. I don't want it to be too long, so that I can continue on other ideas. So this is some general introduction to the idea of trigonometry, which we see to be three angles measurement. So I've explained some some basic ideas about triangles. So we'll continue in the next video as I talk about some foundations of trigonometry. Come along. If you have not subscribed to this channel, please do that and be sure to hit on the notification bell so you can get notified whenever I release a new video. See you in the next one.